Okay, finally we're on page 6, and at the top of the paper we're reminded of what the Pythagorean theorem says. The leg squared plus the leg squared equals the hypotenuse squared. There's a picture over there to go with it. And in this exercise, the legs the leg B is 5 inches. I'm going to redraw this down here. This is 5 inches, and the hypotenuse, labeled with the letter C, is 13 inches. We want to find the length of the other leg, which is labeled A. So, following this guideline, leg squared plus leg squared equals hypotenuse squared. So 5 squared plus A squared equals 13 squared. And if I change those, we get this. 25 plus A squared equals 169. And I'm going to get the A squared by itself, take away 25 from both sides, and then we have A squared equals 144. Now I believe this is the first time we're doing this semester. We've got something squared equals a number. We're going to solve this by taking the square root of both sides of the equation. Remember the old thing that you can do whatever you want to one side of the equation as long as you do the same thing to the other side. So if I take the square root of A squared and take the square root of 144, I get A equals, and really being very formal, there are two solutions to this, plus or minus 12. Two solutions to this equation, but since we're talking about the length of the leg, we're not going to use the negative value at all. The length of that leg would be 12. 12 squared plus 5 squared would give you 13 squared. So that's the end of that. A few more examples of taking care of this sort of business. Oops. Trying to zoom in, and I did something strange. Okay, anyhow, fourth root, 32 is not a perfect fourth power. If we divide by 2, we get 16. 16 is 2 to the fourth power. So we like the number 16 in this setting. For the variables, remember we want the exponents to be divisible by 4. So the h to the 19th, I'm going to rewrite this h to the 16th, h to the 3rd. And by the way, in the previous video, it got cut at the end because a phone call came through and stopped the camera. So sorry about that, but it was just a few more seconds to go in that one. 20 is already divisible by 4, no need to factor there. So what's going to change? This will change, this will change, and this will change. This changes to a 2. This changes to h to the power. 16 divided by 4 is 4. And this changes into p to the power. 20 divided by 4 is 5. And what remains underneath our fourth root radical? A 2 and a h to the 3rd power. 2h to, wow, look at that. So 2h to the 4th, p to the 5th times 4th root of 2h to the 3rd. And here's a nice little cube root exercise. 40 is not a perfect cube. Divide by 2, you get 20. That doesn't do us any good. You can't divide it by 3. Divide it by 4, you get 10. That's not a perfect cube. Divide it by 5, you get 8. Hooray for 8. 8 is a perfect cube. There's our 40 factored. This is not divisible by 3. 20 is not divisible by 3. Neither is 19. But 18 is. So I'll factor that. X to the 20th into x to the 18th x to the second. And 15 is divisible by 3. So I'll leave that alone for the moment. And now this simplifies, and this simplifies. This becomes a 2. This becomes x to the 6th, 18 divided by 3. And this becomes w to the 15 divided by 3 is 5. And what do we put back under the cube root radical sign? A 5 and an x squared. Let's double check for accuracy. Yeah, I believe that's all. By the way, if any of these videos have mistakes, please let me know as soon as you spot them. So, do not claim to be perfect. Okay, one last, and then we're done with the Friday lecture. We want to add these, but they're not like radicals, not yet. After we simplify, maybe something will happen to allow us to combine them. Here's a few, it's fourth roots, so here's the first few, there's 1 to the 4th, 2 to the 4th, 3 to the 4th, etc. Oh, we're looking for those numbers to pop out. So 512 is not in the list, but if you divide 512 by 2, you get 256. So I'm going to rewrite the 512. I'm going to rewrite, I should say, the fourth root of 512 as fourth root of 256, fourth root of 2. And 7 is not divisible by 4. So I take that x to the 7th and break it up into x to the 4th, x to the 3rd. So all that work just for that. Let me zoom out just a tad. Plus 11 fourth root of 162 is not a perfect fourth power, but if you divide 162 by 2, you get 81. 81 is a useful number here, perfect fourth power. And then there's that x to the 7th again, so we'll treat it the same way. Okay. Whoops, I need a little more room here. Zoom out just a bit more. Lengthy exercise, eh? So, this is going to change, and this is going to change, and this is going to change, and this is going to change. What do we have now? 5, and 256 is 4 to the 4th power, so that's 5 times 4 times x to the 1st, and what we have remaining under the fourth root radical is a 2 and an x cube. And then over here we've got that 11 coefficient. This is the 4th power of 3. Fourth root of 81 is 3. And of course that's an x. And blah, 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 blah. And when we finish with the little multiplication step now, what do we got? 20x fourth root 2x cube plus 33x fourth root 2x cube. Oh boy. X fourth root 2x cube, x fourth root 2x cube. We do have like terms here, which include like radicals. 20 plus 33, that's 53. 53x fourth root of 2x cube. That is our final answer. And that concludes lecture number 20. Thanks for watching. Bye-bye.